Hello! We are still doing some relativity. In the last video, we learned about how time would dilate and get longer as some people were traveling near the speed of light, or maybe shorter. But also, when things are traveling near the speed of light, length starts to do crazy things like contract and things get all squished up. So this video will be all about length contraction. Let me walk you through an example of why length contraction has to happen, or otherwise bad things would happen to the rules that make up our universe. Let's say that we've got our friend Astro Frank. And Astro Frank is going to fly a spaceship at 0.8 times the speed of light to Alpha Centauri, which is something like 4 light years away. And the people on Earth are going to measure this and they're going to cheer him on the whole way. According to Earth, if he goes at this speed, it might take him about, they say, oh, that took you about 5 years from the Earthling's point of view. And if you do 4 light years divided by 5 years, that's going to give you a reasonable speed, something like 80% the speed of light, no problem. However, Astro Frank says, hey, I'm measuring proper time because this event is at rest relative to me. So we know that proper time must be shorter or non-dilated. So he says, it only took me 3 years. Suckers! According to him, that's a valid measurement. So his velocity would be something like a distance of 4 light years divided by only 3 years worth of time. Astro Frank has violated the laws of physics because he's now traveled faster than the speed of light. This cannot happen. The distance that he went must have contracted, because we're going to accept the second postulate of relativity that the speed of light is always the same and nothing can travel faster than. Astro Frank did not break the speed of light because his distance was actually not 4 light years. According to him, it was a contracted length. Now both the length to Alpha Centauri measured by the Earthlings and the length measured by Astro Frank were both valid and correct measurements. But we're going to say that the Earthlings measured the proper length. Take a minute and pause it and write this one down. We call it the proper length because the people on Earth were at rest relative to that distance, whereas Astro Frank was zipping past that distance. And if you measure it in that way, or any other length in that way, you will measure a smaller or a contracted length. So remember that proper length is always the longer one. The length you move relative to is always squashed. The equation for length contraction is going to be pretty similar to the time dilation one, where this will be proper length here. This is your Lorentz transformation, which hopefully you remember as being equal to square root of 1 minus v squared over c squared. And remember, this is always greater than 1. So if you divide the proper length by a number greater than 1, the contracted length, which is this here, will be shorter than the proper length. Now, based on that equation, see if you can solve this problem here. You should destroy this problem. Pause it, give it a shot. Now, first thing is you want to know, are you trying to find the contracted length or the proper length? The ship, you're stationary, and the ship moves past you. So you are not measuring proper length. You are measuring the contracted length. So if you use this equation, what we're searching for here is going to be the proper length, L sub O. First you need to find out what's your Lorentz factor. You know it is going to be this squared divided by c squared. If you then do the math, which you should have already, you should get a Lorentz factor of about 2.29. So then, if you take your contracted length that you measured of 250 meters, and set that equal to the proper length divided by the Lorentz, which is a unitless number, you should get a proper length, a longer length, as measured by the aliens of something bigger, of something like 570 meters, which is a longer proper length, as it should be. There's a famous relativistic quandary, I don't know if that's a word, called the twin paradox, where let's say you've got two twins who are hanging out on Earth. One we're going to call Earth Ed, because he's not going to leave the Earth, and the slightly crazier, adventurous one we're going to call Astro Fred. And Astro Fred is going to go on a mission. He's going to get in his, they're both 20, because they're twins, and 20 years old. Astro Fred's going to get in his rocket ship. He's going to blast off. He's going to go high-five the magic space unicorn that's very far out here. He's going to travel at a crazy fast speed. Let's say it's something like 0.9 c, or 90% the speed of light. High-five the unicorn, and then he is going to come back. So Astro Fred comes back, and he thinks he's been gone, looks at his watch, for 20 years, and he's now 40 years old, middle age. And he says, Ed, what's happened to you? Ed is an old man. Ed has a beard and a cane. And Astro Fred says, Earth Ed, what in the world has happened? And Earthbound Ed says, young whippersnapper, you are crazy, you don't even know. He goes, I measured dilated time while you were gone. Because the event that was happening was you flying all over the place, and that event took place within your time frame. I was just an observer. So I measured the dilated time, while the time you measured was the proper time. And Astro Fred says, that makes sense, but here comes the paradox. Astro Fred, who's always been a little crazy, said, hold on there, old man. I see things differently. Why can't we say? And he goes, here's what I saw from my point of view. I was just hanging out in my spaceship. In fact, I never really did anything in my spaceship, and then suddenly the Earth just zoomed away that way, and then this unicorn came and high-fived me, which was strange. I never did anything in my spaceship, and then the unicorn zoomed away, and then the Earth came back. Astro Fred says, I think that I remained stationary, and you guys went on a journey. And by that case, I should be measuring the dilated time, and you should be measuring the proper time, the proper or shorter time, and you the one who had an event, which makes it seem like a paradox, because you kind of think maybe he could be correct. But the reason that this is incorrect and not actually a paradox is that he accelerated in his rocket ship when he left, and also when he turned around as well. And so since he accelerated, that means that he was not in an inertial reference frame. So he can't make that claim that he was stationary and everything else was moving, because he would have felt the acceleration, and no one on Earth felt the acceleration that Astro Fred claimed.